So question 4, the heights reached by a species of small plant are measured by a team of biologists. Pretty sure that's botanists, but anyway, the results are shown in a histogram of relative frequencies shown below. So let's slide down and see what's going on for the first question. We've got to work out the chance that a mature plant reaches no higher than 30. So let's have a look here. Here's if we basically want the heights of these two histograms here. The first one here is 0.04. The second one here looks like it's 0.08. We add them together and we've got 1 mark on the scoreboard. Then to move on to the second part, if a mature plant reaches a height of at least 32, what's the chance its height reaches above 38? So we've got another conditional probability happening here, or rather a conditional probability. So given that it reaches at least 32, so we're not interested in any of these plants over here, we're just interested in 32 and upwards. So that's the first thing we need to calculate here, the probability that the height is greater than 32. With a couple of ways, but it's pretty quick to add up the numbers here rather than subtract anything. So just reading the values off the scale to get 0.52. And then the condition, given what is the probability the height is at least 38. So here's back to the question. So that's this little bar over here, which is only 0.02. And so therefore our conditional probability is 0.02 divided by 0.56. And that's one of those fractions that it's fairly impolite to leave it looking like that. So we multiply them both by 100, halve them both, and we got 1/28. So there's the next 2 marks. And over the page, the question carries on. Part C refers to a new height distribution. Again, another team of botanists probably is meant to be, is studying the mature heights of a species of hedge. I was pretty sure that hedges were made up of species of plants. But anyway, I found a couple on the internet. Here's a kind of concentric circle species of hedge, and here's a zigzag species of hedge, and here's a bare species of hedge, just in case that's maybe what they're talking about. Anyway, what percentage from the study reach a mature height of less than 2? So we're only dealing with this top function here, and we simply need to integrate it from 1 to 2. So I've split it h over 5 minus 1/5 just to make the integration a little bit simpler. We've got h squared on 10 minus h on 5 from 1 to 2. Substitute in 4/10 minus 4/10 minus 1/10 plus 2/10 leaves us with 1/10. They've asked for a percentage, so I'm guessing we've got to answer 10% for the third mark on that one. Then we're on to part D of this question. So part D, determine the value of K. So we need to look at the second part. So we know that if we integrate this function between 2 and 4, we have to end up with the other 90% because we've got 10% of heights accounted for in the first part. So we need to set ourselves up another integral. I've just integrated h squared. Notice there was a k in the question, but I kind of don't bother with the k until afterwards. So if we just integrate h squared from 2 to 4, we end up with 56 over 3. And hence from that we know that 56 over 3 multiplied by k must give us the 9/10. And a little bit of multiplication, 3 9s are 27. Multiply the 56 downstairs and we've got 560. So k is 27 over 560. And I'm pretty sure that one doesn't simplify for the last 3 marks.